I'm Joe Graydon.
And I'm Terry Graydon. Welcome to this podcast of the People's Pharmacy.
You can find previous podcasts and more information on a range of health topics at peoplespharmacy.com. Today, we're talking about probiotics and how they impact our health. We'll also learn about a link between cold sores and dementia. This is the People's Pharmacy with Terry and Joe Graydon.
Dr. Eran Elinoff and his Israeli colleagues discovered that each of us carries a collection of microbes as unique as our fingerprints. Antibiotics can have a devastating impact on this community of microorganisms we call the microbiota. How can we reestablish ecological balance after antibiotics?
A British researcher has been studying the link between herpes virus infections and Alzheimer's disease. Will antiviral drugs reduce the risk of developing dementia?
Coming up on the People's Pharmacy, an international health news update.
First, the news.
In the People's Pharmacy health headlines, people with troublesome arthritis pains in their knees may want to consider changing the menu. A small study conducted at the University of Alabama in Birmingham compared the effects of low-carb and low-fat diets on joint pain. 21 arthritis sufferers between 65 and 75 years old were randomly assigned to one of these or their usual diet for 3 months. The investigators assessed the participants' pain and quality of life every 3 weeks during that time. People who followed a low-carb diet had less pain and were better able to walk for a distance and stand up from sitting. The researchers specified that the improvement could not be attributed to weight loss alone. Diet quality was paramount. A healthful low-carb diet with lots of leafy vegetables and healthful fats such as nuts and olive oil may not be quite as effective for pain relief as NSAIDs or opioids. On the other hand, such a diet is less likely to have unpleasant side effects than the drugs.
A study presented at the annual meeting of the Endocrine Society has challenged standard medical practice when it comes to the diagnosis of diabetes. Over the last few decades, many doctors have relied on a blood test called the hemoglobin A1C to detect elevated blood sugar over several weeks' time. But when researchers compared HbA1c values to the results of oral glucose tolerance testing, HbA1c was much less sensitive. The data came from 9,000 adults who had not been diagnosed with diabetes. In a surprisingly large number of cases, people with normal HbA1c values reacted to sugar as people with diabetes do on the oral glucose tolerance test. The authors caution their colleagues not to rely exclusively on the HbA1c test to diagnose diabetes.
Vascepa is a prescription pill containing one of the types of omega-3 fatty acids found in fish oil. This medication, icosapent ethyl, is prescribed for people with stubbornly high triglycerides. Now, researchers report that people taking Vascepa are 25% less likely than those on placebo medicines to suffer a heart attack, stroke, or other serious heart problem. The study included more than 19,000 people with heart disease or serious risk factors for heart disease. About 6% of those on Vascepa suffered a heart attack during the year-long study, compared to 8.7% of those on placebo. Serious side effects included atrial fibrillation and severe bleeding events.
We don't usually report on litigation. That said, however, there were 2 big settlements this week that deserve attention. The Purdue Pharma Company agreed to pay $270 million to the state of Oklahoma for damages attributed to OxyContin. This opioid has been center stage in the epidemic of painkiller abuse in the United States. Other states and local governments have also brought suit against the company. An even larger settlement was reached by Bayer and Johnson & Johnson involving the anticoagulant Xarelto. The companies will pay $775 million to settle over 25,000 lawsuits. Patients or their surviving family members claimed that they were not told the drug could cause potentially fatal bleeding. Neither Bayer nor J&J accepted liability.
Giving birth can trigger a flood of intense emotions from joy to anxiety. Some women experience deep despair, known as postpartum depression, that can last for months. Women with this condition are often severely impaired in their ability to care for themselves and their babies. Current antidepressants take months to work. The FDA just approved brexanolone to treat postpartum depression. It works relatively quickly. After a 60-hour infusion, women participating in the trials showed improvements on a scale designed to measure depression. For women suffering severe postpartum depression, the difference from placebo was significant. The drug, to be sold under the brand name Zulresso, carries a number of risks, including excessive sedation and loss of consciousness during the infusion. It's also extremely expensive. Uninsured women, and even those with some insurance, may have difficulty footing the $34,000 bill. And that's the health news from the People's Pharmacy this week.
Welcome to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. Today, we offer you an international health update. Researchers in Israel and the United Kingdom have made some fascinating discoveries about how our interactions with microbes can help shape our health. Later in the show, we'll talk with a scientist who's been studying the possible link between cold sores and the risk of dementia.
But first, we're talking with Dr. Eran Elinoff. He holds the Sir Mark and Lady Tanya Feldman Professorial Chair in Immunology at the Weizmann Institute of Science in Israel. He's also the Howard Hughes Medical Institute and the Bill and Melinda Gates Foundation International Research Scholar. In addition, Dr. Elinoff is a Senior Fellow at the Canadian Institute for Advanced Research.
Welcome to the People's Pharmacy, Dr. Eran Elinoff.
I'm very happy to be speaking to you.
Dr. Elinoff, I suspect that a lot of our listeners have heard about probiotics and gut bacteria. This has become a very popular subject in the U.S. over the last decade or two. But I think there's still some uncertainty about the role of all of those bacteria, fungi, viruses, all the stuff that's living in our digestive tract. How important is it to our health?
Well, this collective world within a world that resides within each and every one of us from the moment we are born until the moment we die is a fascinating ecosystem of microorganisms that only has been thoroughly studied since around 10 to 12 years ago. And during this period, we were quite amazed to find out that this bacterial universe that lives within us is absolutely important to almost any physiological function of the human body. And in fact, we regard all the trillions of microbes that live within us as an integral part of the human body. And as such, they are not only extremely critical to the maintenance of our health, but are implicated in a growing number of common multifactorial human diseases.
I think the idea of our microbiota as an integral part of us is taking some people a little while to adjust to. I also want to ask you about probiotics because a lot of people have the idea that, yes, I've got these bacteria in my digestive tract and I need to tone everything up, so I'll take a probiotic. Is that a reasonable approach?
Well, the probiotic approach has been with us for decades. Actually, it has been with us even before we've been able to revisit the world of the microbiota. And, at first, it seems to be intuitively very straightforward. We have many bacteria within us. Some of these bacteria may be associated or even cause or contribute to human disease. Let's give ourselves a quote-unquote good bacteria and cancel out this adverse effect. But when we use the very advanced tools that have been developed in the last decade as part of the microbiota field, we seem to realize that this is not so simple. And in fact, everything that we believed about probiotics need to be revisited using these approaches in order to optimize probiotic therapy in humans.
Tell us a little bit, please, about those advanced tools and what you found in your recent research.
The advanced tools that we utilize regularly in the last 10 or so years as part of our microbiome research include very advanced genomic approaches that enable us for the first time to characterize in great genomic detail the trillions of microbes of thousands of different families that reside within us in different signatures that are quite unique to each person. And these are coupled with other technologies that enable us not only to characterize these microorganisms that reside within us, but to actually start to scrape the surface in understanding how they contribute to different features of our health or to our propensity to develop, in some cases, important and in some cases even dangerous human diseases. Now, with regard to probiotics, the really vast amount of literature that has been out there in terms of trying to understand what they do and in which cases these exogenous microbes are potentially helpful for human health has met multiple limitations. One of the biggest limitations which we approached in our studies is the fact that in almost all previous studies, probiotics were studied in stool rather than directly at the place where they're supposedly active, which is the inside of our gut, the inside of our gastrointestinal tract. Without this direct observation, it is very difficult to make good scientific conclusions on whether probiotics colonize the human gut, and if they colonize, and in which cases they colonize, or let me rephrase, in the cases in which probiotics colonize the human gut, we know absolutely nothing, at least based on direct observation, whether they impact important features of the indigenous microbes and the activity of the human gut. So we decided to try to contribute to this knowledge base by looking very aggressively and very invasively for the first time at the inside of people's gastrointestinal tract. And by doing so, we attempted to directly learn and address the concept of probiotic colonization within the human gut or lack thereof. And in cases in which we would find probiotics to be able to reside within the human gut, we wanted to see what they do there in terms of their interaction with the internal microbes and their effect on the human side of the gut.
Well, I think most health professionals, and for that matter, patients, have no idea what's actually going on inside their digestive tracts. I mean, they think, oh, yeah, I've got this long tube, the colon, for example, and there are hundreds of millions, maybe billions of bacteria, fungi, viruses, and they're just all hanging out. But I suspect it's a lot more complicated than that, especially at the inner lining, the mucosal lining of the digestive tract, where they actually set up shop. Can you give us some better sense of how all of these microorganisms are interacting with one another and with our tissues?
This is a great question because indeed we know very little on how these huge and diverse neighborhoods of microbes that live along the lining of our healthy gastrointestinal tract actually communicate with each other and communicate with our human cells, with the human side of the gastrointestinal tract, in helping the gut perform its really vital set of functions. We don't know the molecular aspects of these interactions. We don't know what goes on in a wrong way that contributes when these communication channels are perturbed to the development of human disease. And we really have very little knowledge with respect to what happens when new bacteria are introduced into this really well-developed neighborhood. And we don't know whether this neighborhood of indigenous microbes that are uniquely fitted to each of our gastrointestinal tract accept these exogenous probiotic microbes and allows them to come into contact with the mucosal layer and to impact human health and physiology, or whether there is a hostile relationship that develops in which these exogenous microbes are met with a hostile neighborhood, which kicks them out and doesn't allow them to colonize the healthy gut. And all of these big unanswered questions have not been addressed directly by looking inside the human gastrointestinal tract. So all the knowledge that we have on probiotics is indirectly based on measurements of stool.
So some of your recent research actually did look inside the human digestive tract. Can you tell us more about that, please?
Absolutely. So we performed two major studies, the first of which aimed to address the question on whether commonly consumed probiotics actually colonize the healthy human gastrointestinal tract. And to address this question in a very direct and invasive manner, we recruited a group of healthy volunteers and we performed an endoscopy and a colonoscopy from above and from below, in which we characterized their indigenous, naive, and healthy gut mucosal microbiome from up until down, and of course their human gastrointestinal tract function. And then we took these volunteers and we divided them into two intervention groups. The first group received a combination of 11 strains of very commonly used probiotics, of the four most commonly used probiotic families, while the second group of volunteers received a placebo pill, basically an identically looking pill that didn't contain anything. All of these interventions lasted 4 weeks, and the unique feature of this study is that after 3 weeks into the intervention, we performed a second colonoscopy and endoscopy in all the volunteers, which enabled us to see what the probiotics were actually doing to the indigenous microbiome and to the host gut gene expression profile.
Dr. Elinoff, how in the world did you ever convince these hardy volunteers to participate in your study in which they would have 2 endoscopies and 2 colonoscopies within a month?
Well, first, we were very persuasive, but seriously speaking, these volunteers realized that the questions that this study would enable us to address would shed light on a habit of consuming probiotics that is practiced by many millions of people worldwide, although we really know very little on what happens when we introduce these bacteria into our healthy gastrointestinal tract. So I think this was really a great motivation for these volunteers to contribute their time and their body to this very important study.
You're listening to Dr. Eran Elinoff, the Howard Hughes Medical Institute and the Bill and Melinda Gates Foundation International Research Scholar. He holds the Sir Mark and Lady Tanya Feldman Professorial Chair in Immunology at the Weizmann Institute of Science in Israel and is a senior fellow at the Canadian Institute for Advanced Research.
After the break, we'll find out how the volunteers' microbiota responded to probiotics.
What does this tell us about the usefulness of probiotics?
How can we help our microbiota recover from exposure to antibiotics?
Are there any adverse effects of probiotics that you should know about?
Learn how the long-term use of antibiotics can affect your microbiome.
You're listening to The People's Pharmacy with Joe and Terry Graydon.
This People's Pharmacy podcast is brought to you in part by Verisana.com.
Verisana Lab offers home health tests that allow you to monitor your hormones and health conditions. You can take control of the quantitative assessment of your health and learn about male and female hormone balance, the stress hormone cortisol, leaky gut, gluten intolerance, or your gut microbiome.
Take a more active role in tracking your health and take 20% off your first order of a mail-in testing opportunity with the discount code PEOPLE. That's uppercase PEOPLE. To learn more, go to Verisana.com. That's VERISANA.com.
Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. If you would like to purchase a CD of this show, you can call 800-732-2334. Today's show is 1159. That number again, 800-732-2334, or you can find it on our website, peoplespharmacy.com. You can also download the free podcast from iTunes.
The People's Pharmacy is brought to you in part by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at verisana.com.
Today we're discussing fascinating discoveries about the ecology of our digestive tract. The microbiota of our intestines is unique to each of us. Many people hope that by taking probiotics, capsules containing certain types of supposedly beneficial bacteria, they'll be able to shape up and strengthen their own microbiota. How well does that theory hold up?
Our guest is Dr. Eran Elinoff. He holds the Sir Mark and Lady Tanya Feldman Professorial Chair in Immunology at the Weizmann Institute of Science in Israel. He's the Howard Hughes Medical Institute and the Bill and Melinda Gates Foundation International Research Scholar. He's also a senior fellow at the Canadian Institute for Advanced Research.
Dr. Elinoff, we were just talking about your experiment comparing probiotics to placebo on the gut microbiome. Please tell us what you found.
Well, we were very surprised to find that people could be very easily divided into two distinct groups. The first group, which we call the permissive individuals, are individuals which allowed the consumed probiotics to settle in and to colonize their gastrointestinal tract. And by doing so, these new exogenous bacteria were able to both alter the indigenous microbiome and to induce transient but very distinct changes in the host gastrointestinal function. The second group of volunteers, which we call the resistant volunteers, were ones in which these exogenous probiotic strains were completely resisted by the indigenous microbes in their gut. So in other words, these individuals were consuming the probiotics for one end, but these probiotics were ending in the other end of their gut without ever being detected, even using the most sensitive methodologies in their mucosal gastrointestinal tract. In other words, these individuals were never colonizing these ingested exogenous microbes. And in these individuals, these non-colonizing microbes were not inducing any changes in the indigenous microbiome or in the human gastrointestinal tract function, in stark contrast to the persistent individuals.
So for those who are resistant to probiotic colonization, taking a probiotic is a big waste of time, right?
Well, at least in the very thorough and many features which we tested, which is the gene expression profile throughout their human gastrointestinal tract and in terms of their effect on the indigenous microbiome throughout their intestinal tract, we saw very little change that would be regarded as meaningful, at least in healthy people.
Well, this might explain why some people who have received a course of antibiotics, perhaps fluoroquinolones like Cipro or Levaquin, or something that's even more challenging sometimes to the digestive tract, like clindamycin, that can often cause something called a C. diff infection after the course of antibiotics, why some people get great benefit from probiotics and other people end up not recovering from the antibiotic, and it may take weeks, months, or in some cases even years to overcome that C. diff infection. Is that a possibility?
Absolutely. Although this part of the study was focusing on healthy individuals, while the second part of our study was focusing on this exact post-antibiotic exposure, the results strongly suggest that the one-size-fits-all probiotic approach, which we all very intuitively follow, in which you go to your supermarket or any other place and you buy probiotics that are generated by the industry and are sold to the entire community in a non-discriminative manner, should be replaced by a science-based, measurement-based harnessing of specific probiotics to specific subpopulations of humans featuring specific medical conditions. In fact, in our own study, we were able to take the microbiome of these volunteers even before they ever were exposed to the probiotics, and using advanced computational algorithm, we could predict who would end up being resistant and who would end up being permissive. This was a really surprising and even an amazing finding that would hint that in the near future, we will be able to use data coming from our microbes and advanced computational technologies that we already are using almost on a daily basis to harness different probiotic combinations to different people at different clinical contexts in order to optimize their colonization and their reproducible impact on the human host. And this would be a really substantial change from this completely blinded, one-size-fits-all approach that we use today, in which we have no say on which probiotics are provided to us by the industry. And of course, we have no means to know whether we are part of the people who would be colonized by this combination of microbes or would be completely resistant to their colonization and to their effect.
We often look at antibiotics as sort of miracles, magic medicines, silver bullets that are going to solve all our problems. And I remember growing up as a teenager that dermatologists would often prescribe broad-spectrum antibiotics like tetracycline to teenagers, not for a week, not for a month, but for years to control their acne. And I'm wondering now, in light of your research, it sounds like when we take antibiotics for weeks, months, or years, that it could have rather profound impact on our microbiota.
You're absolutely right. On the first hand, I do agree, and I'm saying this as a clinician, I do agree that antibiotics are really sort of a miracle. Within less than a century from their discovery, they've really transformed human health and have addressed very effectively the cause of disease and the cause of mortality that was the number one cause of human morbidity and mortality for thousands of years, which is infection. So in that aspect, I think that antibiotics are really an amazing discovery that really transformed human lives. However, we are increasingly learning the price that we pay for antibiotic administration, especially when non-indicated. And one of the biggest prices that we unfortunately pay is exactly the one that you've noted, which is that antibiotics often disrupt in a very profound manner the normal configuration of our internal microbes, and especially the configuration of our gut microbiota. And when persistent and when substantial, this alteration of the normal and healthy microbiota configuration may lead to substantial risks of developing metabolic diseases such as obesity, type 2 diabetes, fatty liver, and there are many complications, especially in people who are genetically predisposed to develop these diseases, as well as other diseases, including allergy and inflammation. So I don't think that antibiotics should be regarded as an evil intervention or as a blessed intervention. It is an intervention like any human intervention, which has very positive aspects when properly administered, but also has meaningful and important adverse effects that need to be known, addressed, and considered when considering an antibiotic treatment.
If you were to look ahead on the horizon and imagine 10 years from now where your field, not just looking at the microbiota, not just looking at probiotics, but looking at immunology in general, what could you imagine once we have been able to, in a sense, analyze individuals, determine what their microbiota looks like, and what probiotics might be beneficial specifically for them? And now I'm guessing, people who have to take antibiotics, people who have inflammatory bowel disease, people who have a range of autoimmune conditions, perhaps even people with dementia. We're now hearing that there's communication between the gut bacteria and the brain. So give us your long-range view of where this field may be headed.
Well, I believe that one of the most fascinating and promising aspects of microbiome research is that the microbiome represents a very unique and very diverse signature that differentiates different humans from one another. Now, why is this so exciting for us? It is exciting because we can increasingly harness the microbiome in order to personalize medical decisions. And this is an integral part of a very exciting new field and era in medicine called precision medicine. Now, what we are doing at my lab and in other labs is using this unique set of features that each person carries in order to impact our medical decision-making process. For example, we can think that in 10 years, we would be able to make decisions on medical treatment based on different people's microbiomes. Today, when, as a physician, I give medications to a person who is affected by almost any disease, it's a trial and error process in which we rely on population-based data, and we give a set of medications to a given condition. If it doesn't work, we try to change it to another set of medications until we reach a signature of medications that seems to do the job. However, using precision medicine, one can imagine that we would be able to sample and to characterize in depth a person's microbial signature and use advanced machine learning and artificial intelligence platforms that we're already using in many of our microbiome studies in order to decide, based on data and based on personalized measurements, which signature or which combination of medications would be optimal for a given person. And the same is true for many different medical indications. One can think of what we call patient stratification, in which a patient comes and is diagnosed with one of the very common multifactorial diseases, such as inflammatory bowel disease or even cancer, and we can characterize that person's unique microbiome features and actually help that person know to which disease subsets he or she belongs to, and therefore direct the treatment in a much more precise and measurement-based manner. We can even think, and there is very good preliminary data pointing towards that if we understand how the different microbial signatures in different people impact disease development and progression, that we would be able to intervene through the microbiome in offering preventive or treatment approaches that would complement the ones that are already in use. So the future is very bright. There are great challenges and obstacles that we would have to address and to really meet. But I think that the field is making great strides, and I'm very optimistic personally.
Dr. Elinov, I have one more question, and that is, one of the promises of precision medicine is not only that we will be able to find more effective treatments, but also that we'll be able to minimize harm from adverse effects. Are there adverse effects from probiotics as they currently are used?
That's a very good question. In general, historically speaking, probiotic use has been regarded as very safe, at least in the short term. However, and there are big howevers here, there are recent very good quality publications that looked at all this overwhelming amount of probiotic data and really found out that adverse effects are underreported in general in probiotic-related studies, which is a bit worrying to us. The second big but is a discovery that we made in the second part of our studies, in which we addressed the potential impact of probiotics after antibiotic use. And you know that this is perhaps the biggest, the most widely claimed indication for probiotic use throughout the world. And to address this question, we recruited a different group of healthy human volunteers. These individuals were kindly asked to take a course of antibiotics for a week, and then we scoped them from up and from down to characterize what happens to their gut, to their microbiome, and to their host side of the gut after antibiotic exposure. And of course, there was a very big disruption in both the human side and the microbial side of the gut, and this has been described well before us. But then we divided these individuals into 3 intervention groups. The first intervention groups, which we call the wait and watch group, is one in which we wanted nature to do its course. We didn't do anything, and we just wanted to see how quickly the gut recovers after a week course of antibiotics. In the second group, we gave the same 11-strain probiotic combination to see what happens when we use this very common human trait of giving probiotics after antibiotic treatment. And the third intervention group was composed of people who were given back their individualized microbiome that was collected before they were ever exposed to the antibiotics and was stored until disuse. After 3 weeks into each of these three interventions, we scoped all the volunteers a second time from up and from down to see what each of these interventions was actually doing to the reconstitution, to the recovery of the gut after antibiotic exposure. And we were quite surprised to find out that the wait and watch, the natural recovery group, took around 3 weeks for their indigenous microbiome and host gut gene expression profile to return to their healthy, naive, pre-antibiotic configuration. However, the people who were taking probiotics were colonizing their microbes in this case because the microbiome, the naive microbiome, was wiped out by the antibiotics. So the exogenous microbes now had a niche and a place to settle in. But once they settle in, they very aggressively and very persistently inhibited the return of the indigenous microbiota back to where it should have been placed. And this inhibition of the reconstitution of the gut was not only very potent, it was very persistent. It lasted for at least 6 months after a single antibiotic exposure of 1 week. In contrast, when we gave back these individuals in the third group their own pre-antibiotic personalized microbiome, they recovered their entire gut and microbiome within 2 days altogether. And this surprising result points to a new and unexplored adverse effect that potentially impacts probiotic use after antibiotic exposure, which is this persistent state of microbiome disturbance, which we call dysbiosis. Now, this is a potentially alarming long-term adverse effect because there is really a large body of data that suggests that a prolonged and persistent disturbance in our gut microbiota after antibiotic treatment may be contributing to diseases such as obesity, diabetes, allergy, and inflammation. And of course, future studies would need to address these potential consequences, but this tells us that we do not know enough about potential adverse effects associated with probiotic administration, especially after gut perturbation, such as with antibiotics.
That is indeed alarming and very interesting. Dr. Eran Elinoff, thank you so much.
It's my pleasure. Thank you very much.
You've been listening to Dr. Eran Elinoff. He holds the Sir Mark and Lady Tanya Feldman Professorial Chair in Immunology at the Weizmann Institute of Science in Israel. You'll find links to his lab and his research at our website, peoplespharmacy.com.
After the break, we'll switch countries and change our focus to a different group of microbes, the viruses that cause cold sores.
You're listening to The People's Pharmacy with Joe and Terry Graydon. Thanks for listening to this podcast of The People's Pharmacy. If you like it, why not rate or review it in the iTunes store? We'd appreciate it.
Welcome back to The People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. If you would like to purchase a CD of today's show or any People's Pharmacy episode, you can call 800-732-2334. Today's show is number 1159. The number again, 800-732-2334. You can also find it online at peoplespharmacy.com. Download the free podcast from iTunes or from our web store. We invite you to consider writing a review.
The People's Pharmacy is brought to you in part by Verisana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. online at verisana.com.
Earlier in this episode, we were discussing microbes that live in our intestines and how we might or might not be able to change them. We turn now to a different part of the body and a quite different type of microbe. Could the viruses that cause cold sores increase the risk of dementia from Alzheimer's disease?
Our guest is Dr. Ruth Izaki, Professor Emerita of Molecular Neurobiology at the University of Manchester. She's also an honorary senior research fellow at the University of Oxford.
Welcome to the People's Pharmacy, Dr. Ruth Izaki.
Thank you. I'm looking forward to talking with you.
Dr. Izaki, it's so fascinating that in the last couple of years, there have been headlines in the United States, and I suspect around the world, linking a herpes virus, in fact, a couple of herpes viruses, to Alzheimer's disease. But when I went searching the medical literature, I found that as far back as 1974, in the British Journal of Psychiatry, there was actually a little article about dementia and antibodies to herpes simplex virus. Why has it taken so long to catch up with that old research?
Well, some of the old research wasn't done with a very sensitive or adequate methods, and there was quite a lot of controversy about the basic fact, which my lab discovered, that by using this technique called PCR, that there really is herpes simplex virus type 1, HSV1, in elderly brains, most elderly brains. Previously, there had been quite some controversy about that, because some people found the viral DNA there and some didn't. And the antibody story, I think, was that they generally didn't find antibodies because probably the amount of viral protein present, or viruses, is very, very small. Usually the virus is latent, probably, and it can reactivate, become active, but even then it must be at a low level, because otherwise it would cause herpes simplex encephalitis, which is not apparent, luckily, in most Alzheimer patients.
Now, Dr. Izaki, when you say HSV1, that's the herpes virus that causes cold sores, isn't it?
It is, yes.
Dr. Izaki, how did you get interested? And this is way back in the 1980s. How did you get interested?
Yes, that's right. We started work in 1989. And I should say, because I didn't mention it in the previous sentence, that we had extraordinary trouble trying to get things published and trying to get funding, because people just did not believe us. It was terrible. I've had about 25 years of that, of really enormous struggles to get the work understood or even read. Most of our opponents didn't even bother to read the publications, I think, but only in about the last 8 years have other people joined in and found results that substantiate ours, and that's when the change of heart started to coming about. Even now, though, there are some diehards who will not accept it. Even, again, I think they don't read the papers, so they don't know what we've said. I mean, the articles, scientific papers.
Now, Dr. Izaki, why do you think that there's been such resistance to the idea of an infectious etiology when it comes to Alzheimer's disease, and especially the herpes simplex virus?
Well, I'm not sure it was hostility just to that particular virus. I think it was hostility to the idea of any microbe being present in brain. When we first published our result, the first results we got were to detect the virus, as I said, by PCR. And that was one of the papers that we had the most trouble with, but people just didn't believe our results. I think the reason, though, that people are so reluctant, there are two reasons. Firstly, very few people in the Alzheimer field knew anything about viruses. That's understandable, because after all, it's a completely different discipline. And the second reason is a less good one, perhaps, that a lot of them have been working for a long time on other aspects, and they just didn't want to risk their work getting superseded, really. And so it's sort of partly pride, I think, but partly lack of knowledge, understandable though it is, that made them think that. I think they thought that if we admit that one microbe is present in brain, then who knows what other people will find. And there was a trend at one time to say that viruses and other microbes, bacteria, might be the cause of a number of diseases, and really the evidence was usually very slim, whereas in our case the evidence, although I say it was really very good. So I hope that answers your question.
Yes, it does. Now, the headlines have been very scary. Does herpes cause Alzheimer's? And you can imagine that, there are literally tens of millions of people, maybe hundreds of millions of people who have cold sores, and maybe they don't even know they have cold sores, but they have signs of the herpes virus in their brain. Now they're afraid, now I'm going to get Alzheimer's disease and there's nothing I can do about it.
Well, this is the trouble is these headlines are extremely misleading. There are 2 points here at least. Firstly, we have no evidence of whether having cold sores leads to Alzheimer's disease because there are no adequate records kept to people who get cold sores, so we just can't look up the records and see what happened to these people. The other point is it's quite important to note that you can have the infection but not have cold sores. Only about roughly a quarter or a third of people who are infected actually get cold sores. The other ones have what's called reactivation of the virus from latency, but only a certain proportion of those people actually do show signs of it, as in cold sores. Same is true of genital herpes, which is caused by a related virus. But I think the headlines in many papers have been saying if you've got cold sores, they imply you're going to get Alzheimer's. Well, the facts just aren't there to say that. It just isn't correct at the moment. We don't know. We don't have evidence. But it's not just having herpes that matters. We found in our paper in The Lancet in 1997, we showed that HSV1 alone is not a cause. Incidentally, it's multifactorial disease. There are many causes, almost certainly, or at least several causes, and we think HSV1 is one cause. But it's HSV1 in brain of people who have a specific genetic factor. It's the two together, the virus plus this genetic factor, and only about a quarter of the population have this particular genetic factor. So this was probably even if you have both the virus in brain and the genetic factor, it doesn't mean 100% certain you're going to get the disease. I'm sure some people do have both and don't get it. There are always exceptions, to the rule. But what our work suggested was that you need to have both, not one alone, not herpes in brain alone, but herpes in brain of people who have this particular genetic factor.
And Dr. Itzhaki, is that genetic factor the one we call ApoE4?
Yeah, that's correct, yes. That was known to be a susceptibility factor for the disease, but we found that the two tied up together.
Can you explain to us how an infection might be linked to Alzheimer's disease? Your recent paper in Frontiers in Aging Neuroscience was corroboration of a major role for herpes simplex virus type 1 in Alzheimer's disease.
That's correct. The reason that I used that title was because there had been some work, very interesting epidemiological work in Taiwan, where they did a population survey. As I pointed out, I think in the review, there's been a lot of our work and subsequently the works of others have shown that there are a lot of links between the virus and the disease. Similar pathways, herpes causes amyloid formation, causes formation of abnormal tau, both things which appear in Alzheimer's brain. But we couldn't claim, and nor could anybody else claim, that these are causal. In other words, we could say there's an association, but not necessarily causal, although we did produce evidence in the Lancet paper that it was probably a cause, but one couldn't be certain. But an epidemiological study is a population study which looks, there are really two ways to prove something is a cause. Firstly, if you stop it successfully with an agent that opposes it, and in this case an antiviral agent, one specific for that particular virus, if that stops or reduces damage done in the disease, slows its progression, then that's very good evidence that it's a cause. And the alternative, which isn't feasible at the moment, is if you can vaccinate against it and prevent the disease. Both these are able to provide a proof of cause, but none of the other work has been able to, not definitely.
Dr. Iczaki, it seems to me that there was some recent research, also I think from Taiwan, suggesting that the antiviral drugs, and we're talking about pretty safe medications, drugs like acyclovir, known by the brand name Zovirax, valacyclovir, known by the brand name Valtrex, that are used regularly to treat herpes-type infections, might be beneficial against Alzheimer's disease.
That's exactly right. Well, that's the main reason why I said causal, because in Taiwan the work suggests very strongly, for the reason I said, that specific anti-herpes agents are stopping, it's rather puzzling result, but I can't go into that, it's complicated, but they seem to be greatly reducing the likelihood of getting the disease. And so that was a very important result. It needs to be substantiated in work in other countries, of course, because it's just one country. But they had a lot of data on their population for insurance purposes. So there was quite a lot of evidence they could find by looking up the insurance data. They got a lot of evidence. So this is one of the two ways in which I said one could prove something as a cause, by showing that you can stop it or reduce the effects by treatment with a specific agent which blocks its action.
So the Taiwanese database is big because it covers everyone in the country. I think.
That's right. Yes, they've got insurance purposes. It's very unusual. I mean, there might not be any other country in the world that does it, that has that sort of those sort of types of data, which is a great pity, because obviously we need to repeat it.
That is exactly what I was going to ask you, is if there were other large data sets that would allow you to do this type of investigation somewhere else.
Sure. Well, we're very, very keen to do that, but I don't think the information is available. That's the trouble. I don't quite know how one finds out. I do know that in, I think, Iceland or Finland, there's quite a lot of information available. So that might be possible there, although Finland, I think, is slightly unusual in the ethnic type is quite different from the rest of Europe and probably different from the United States in many ways. So it might, I think one really ought to look at it in various countries.
Now, Dr. Iczaki, I suspect that there are a lot of people who are saying, but wait a minute, I'm at high risk for Alzheimer's disease. Grandpa had it, grandma had it, dad had it. I do get cold sores. Maybe I should just ask my doctor for a prescription for, let's say, valacyclovir. It's not that expensive. It's reasonably safe, in fact, safer than most other medications, certainly far safer than most of the drugs that are prescribed to prevent Alzheimer's disease or treat it. Why shouldn't I take action now?
Well, I have suggested this as a possibility in my review, that people who are middle-aged, which is probably a stage at which the virus gets to the brain from outside the brain, that there might be a possibility of treating them, which would be no more expensive than using statins, which are at the moment highly used, to prevent heart disease. This could be so exactly what you're saying. The only thing I would point out is that if somebody says their parents or grandparents or whatever, a lot of relatives have had the disease, it might be that they have the very rare inherited form. And what we're saying does not necessarily apply to that. About only a few % of people with Alzheimer's do have the inherited form. But no, really, it's not necessarily the case that the virus is involved at all. We don't know, because we've not done any work on that, nor has really anybody else, at least not on the viral aspect. So I think if people in the family if there are a number of people in the family who have the disease, it probably is the rare, very rare inherited type. And really, one can't make any comments about that.
Okay.
But as I said before, having cold sores we have no evidence that cold sores leads to Alzheimer's.
But if you had the ApoE4 gene and cold sores, that would put you into this high-risk category that you've written about.
That is probably true, but we have no evidence to say that, because people have not got records of those who have. There are no records made about people with cold sores, so we cannot find out whether or not those with cold sores do mostly develop Alzheimer's. And there's another point here, that not everybody with cold sores has an ApoE4 allele. There are only about 2/3 of the people who have cold sores, in other words, obvious herpes infection and trouble from it, only about 2/3 of the people have an E4 allele. So the other 1/3 might well never get it.
Dr. Itzhaki, our time with you is almost up. So I would like to know, what should our listeners take away from our conversation today?
That it's high time that there are clinical trials, I think, made of antiviral agents to treat Alzheimer's patients, and even antiviral trials for people who are in middle age who try in the hope of preventing it. But there's a lot more work that needs to be done. So there's, I suppose, the main things. And people with cold sores should not necessarily be afraid, because they might well not have the risk allele, this ApoE4.
Dr. Ruth Itzhaki, thank you so much for talking with us today on the People's Pharmacy.
Not at all. I'm very pleased to have talked with you, and I hope the rather complicated story isn't too complicated. But, as usual with research, there are lots of complications and ifs and buts.
Thank you very much, Dr. Itzhaki. Lots of ifs and buts. Dr. Itzhaki is Professor Emerita of Molecular Neurobiology at the University of Manchester. She's also an honorary Senior Research Fellow at the University of Oxford. We have links to her research at our website. We think you'll find it quite fascinating.
We spoke earlier with Dr. Eran Elinav, the Howard Hughes Medical Institute and the Bill and Melinda Gates Foundation International Research Scholar. He holds the Sir Mark and Lady Tanya Feldman Professorial Chair in Immunology at the Weizmann Institute of Science in Israel and is a Senior Fellow at the Canadian Institute for Advanced Research. You'll find links to his lab and his research at our website, peoplespharmacy.com.
And you know, Terry, I really think that Dr. Itzhaki is right. It's time for actual clinical trials to see if these antiviral drugs can have any influence at all on the development or progression of Alzheimer's disease, especially in people who have that ApoE4 allele, that genetic susceptibility. I'm afraid these drugs are available generically, so probably the drug companies won't have any incentive.
No, so we'd have to have some other funder, perhaps a government, that would be interested in undertaking that.
Well, that's all the time we have. Lynn Siegel produced today's show. Al Wodarski engineered. Dave Graydon edits our interviews.
The People's Pharmacy is produced at the studios of North Carolina Public Radio, WUNC.
The People's Pharmacy theme music is by B.J. Liederman.
The People's Pharmacy is brought to you in part by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at verisana.com.
To buy a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is 1159. That number again, 800-732-2334, online at peoplespharmacy.com.
When you visit our site, you can share your thoughts about today's show.
At peoplespharmacy.com, you can sign up for our free online newsletter or subscribe to the free podcast of the show. You'll never miss another episode, and you can share it with a friend.
When you sign up for the newsletter, you'll get our free e-guide to favorite home remedies.
In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thanks so much for listening. Please join us again next week.
We hope you enjoyed this podcast. If so, please consider taking a minute to write a review on iTunes. And thanks for listening to The People's Pharmacy.